back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the lesson on proving trig identities, and in this video I'm going to be going through one more example of proving an identity, and it's followed up by solving an equation. Okay, so here we have part A. Show that 1 minus cos 2x over sin 2x is equivalent to tan x. So what we're going to do is we're going to start off with this side of the identity, and we're going to try to show that it equals tan x. But remember what I said in the previous video, what's your penultimate line going to look like? What's the second to last thing that you write down before tan x going to be? Now in this case it's likely going to be sin x over cos x. So we're going to manipulate the left hand side of this, and we're aiming to get to sin x over cos x because we know that that's tan. So here we go then, starting off with the left hand side, 1 minus cos 2x over sin 2x. Now remember those double angle identities that you've got to know forwards and backwards. You've got 3 options for cos 2x, there's only 1 option for sin 2x. So let's substitute 2 sin x cos x for sin 2x and see what that begins to look like. Right, so 2 sin x cos x. Now, let's think again, what's my penultimate step going to be? Sin over cos. So I want to leave that cos there. And I want to think about a way of cancelling the sin x. And that's leading me to the decision that I'm going to make about what to do with this cos 2x. Because I've got 3 options. And the option I'm going to take is the 1 minus 2 sin squared x option, because I'm hoping that that's going to help me to cancel with the sin x on the denominator. So I'm going to rewrite it again, replacing cos 2x with 1 minus 2 sin squared x. And note the use of the bracket there because I'm subtracting both terms. And that's over 2 sin x cos x. Now look at the numerator. 1 minus 1 is 0. Subtract negative 2. It's going to be 2 sin squared x over 2 sin x cos x. And you can probably see how once again this has worked out quite beautifully. These tend to. You can cancel the 2's. You can cancel one of the sin x's on the numerator with the sin x on the denominator. And that is going to give us sin x over cos x, which is tan x. Identity proved. Quite easily done. Okay, now looking at part B then, where it says hence or otherwise. Now this word hence, when it comes up in exam questions, it means you've already done some of the work. So think, how has what I've just done helping me to answer the rest of the question? So we've got 1 minus cos 2x over sin 2x equals 2. Now you might be tempted to try to manipulate this left hand side, but there's no need to, because look, you've done it in part A. You've shown that 1 minus cos 2x is the same as tan x. So by that same logic, you can assume that in part B, tan x is equal to 2. So all you then need to do is solve the equation tan x equals 2 for values of x between 0 and 2 pi. I'll leave that one to you, I'm not going through that, you should be able to do that still on your head. Because the key thing from this was the trig identity. And look once again at how important that penultimate step to aim at was in terms of determining our journey through this proof. Thank you very much. Job done.